So you're audible. Just a second, please. Hello, everyone. Good evening, dear authors and invited guests. Welcome to Technical Session 9D. Myself, Ishita Sauryan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2026, Pune, India. The 10th edition of this conference is being held in a hybrid mode. The physical event was held yesterday in Pune, and the virtual event is being held through Zoom from the 19th till the 21st of January 2026. I hope you will all enjoy the knowledgeable interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answer. On 9 minutes, I will raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we get started, I'd like to introduce you all to our session chair. We have with us Professor Archana Burujwale, who is an assistant professor in the Department of CS and Engineering, Artificial Intelligence at Vishwakarma Institute of Technology, Pune, India, with over 12 years of academic experience. Her research focuses on development of and computer science within AI, deep learning, with strong emphasis on practical applications. We welcome you, ma'am. We'll be beginning with our paper presentations. I'd like to invite our first presenter, Bhanu Pratap Mohite, with the paper titled A Blockchain-Enabled Framework for Pharmaceutical Supply Chain Traceability. So if you're ready, then you may start with the presentation.
So my paper's name is Blockchain-Enabled Framework for Pharmaceutical Supply Chain Team. I am author of Bhanu Pratap. Authors Gaujay, Ramesh Vishnu. So we are affiliated to JSPM's Rajesh College of Engineering. So talking about our problem statement. So our problem set is uh, the pharmaceutical supply chain suffers from lack of transparency and traceability, and main issue is the counterfeit medicines also. So as we see in COVID era, that most of the issue was that the cold chain of the COVID vaccine was not maintained properly. So we tried to counter this problem. And we, in previous supply chains, we use manual and centralized system, but we have proposed a decentralized solution by using blockchain. So challenges in pharmaceutical supply chain. So previous challenges was transparency, like limited information sharing among stakeholders, then traceability, like we can't trace where actually the product is getting to the customers. Then consumer visibility, like limited access to information, like we were relied on the distributed for the information related to vaccine. So if we compare the previous traditional supply chain and today's our solution blockchain enabled supply chain, then it counters different problems like traceability. Like in traditional, we have manual and fragmented tracking across stakeholders, while in blockchain we use end-to-end automated traceability codes. Then transparency, we focus on transparency, like blockchain use shared ledger, like which is shared across all the nodes in the supply chain. Then data integrity, like blockchain gives immutable and tamper-proof solutions. Then counterfeit detection, auditability, and mostly importantly security, like blockchain is a decentralized solution, so it is not relied on the cloud platform for storing the data. Also blockchains provides cryptographic variability. So how we are going to counter this problem, like if we consider the actual scenario of supply chain of pharmaceutical industry. So if we have worked on proper basically on vaccines which need a cold supply chain management. If we consider the vaccines of tuberculosis or COVID-19, then around 40% of tuberculosis vaccines get damaged due to not maintaining the supply chain and not maintaining the cold supply chain. Like tuberculosis vaccines need 2 to 6 degree temperature, or for COVID vaccines it need 2 to 8 degrees Celsius. So our main focus was to maintaining the cold supply chain and tracking its if the cold supply chain is maintained properly or not. So if we talk about the overview of our project or of our paper, so is that, so first we manufacturer will create the batch for that product. Like then it will be scanned by QR code, which will generate unique QR code, because each hash for that blockchain has each unique hash, so it will generate a unique code associated to each. Then every stakeholder from manufacturer to distributor, wholesaler, retailer will scan the QR code and record transactions of the blockchain. All record will be stored in decentralized and immutable ledger. We are focused on using in our survey paper, we have focused on using Hyperledger Fabric algorithm, which works on raft consciousness mechanism. This is a lightweight solution, and it is a private blockchain solution. Consumer and the end user can scan the QR code to verify authenticity of the vaccine and complete journey of the medicine. This approach prevents counterfeit drugs, ensures security, trust, and if the cold chain of the vaccine is maintained throughout or not. So proposed blockchain framework by us is like the proposed framework is permission blockchain system designed to secure transport and traceable pharmaceutical supply chain. Then only authorized stakeholders such as manufacturer, distributor, wholesaler, hospitals, regulators are allowed to participate in the blockchain. Like we have proposed the solution for private or consortium blockchain networks. Each medicine batch is assigned a unique QR code which acts as a digital identity throughout its life cycle. All supply chain events will be recorded and immutable blockchain transaction. So every transaction will be validated from blockchain algorithm, which is created by on smart contracts, and the data related to that blockchain data, like if the temperature of that vaccine from this point to this time will be stored on IPFS storage. And the framework uses smart contracts and the raft consciousness algorithm for this network. Then so that's it. That's all. I think. And I think this is a system architecture. Like IoT sensor will generate the data. Like we have used IoT sensors like ESP32 and DST11 and 22 will record their data. This data will be passed to the blockchain, passed to our backend server. This backend server will pass this data through the blockchain network, and if the transaction is valid, then it will get recorded in blockchain, and if there is an anomaly, then it will flag that anomaly, like when the actual problem in the data occurred. Thank you.
Hello, am I audible?
Yes, ma'am, you're
Hi.
audible.
Yes, ma'am. Hello,
Actually, I
Ishita.
joined late. Yes, your paper title is the blockchain based, no? Blockchain based pharmaceutical supply chain management, right?
Yes, ma'am. Yes. Hello.
So, can you just tell me that how this framework can handle the scalability if you deploy, if you plan to deploy it across the, suppose the large pharmaceutical networks? Have you tried for it?
No, ma'am. We have proposed the solution. Like most of the major companies are working on this solution. Like if we consider Cipla or the American company Pfizer, they start working on this problem statement from 2020, I think around, because the issue of full supply chain management and the far why this framework is most efficient, because blockchain will just ensure that the data will not be get the data will always remain tamper proof, and we are not storing all data on the blockchain, though we are just checking authentic data will be get stored on the blockchain, and the remaining log related to that blockchain will be stored on IPFS storage, which is interplanetary file storage. So I think this is it. Hello, huh? Hello. Hello.
Yeah, so you're audible. I believe ma'am's voice isn't audible.
Okay.
Ma'am might be having a network issue. I think we'll proceed with the next presentation. Thank you, sir.
Thank you, ma'am. Thank you, Ishita.
Thank you. I'd like to invite our next presenter for the session. We have Avinash Pala with the paper titled carbon-aware serverless scheduling using regional carbon intensity forecasting and workload-based modeling. So if you're ready, then you may start with the presentation.
Yeah, just a second. Am I audible?
Yes, sir, you're audible.
Yeah, just share my screen. Okay, is my screen visible?
Yes, sir, it is visible.
Yeah, okay, let me just start with the presentation. Uh, yeah, okay. So good morning, good afternoon, everyone. I am Avinash Pala, and today I will be presenting a paper titled Carbon Footprint Analysis for Serverless Functions using regional workload-based modeling. So this work focuses upon understanding how regional grid carbon intensity and hardware lifecycle effects influence and sustainability of serverless computing. So now let me take you through the introduction of our project. So basically, cloud computing has transformed how applications are built and deployed, but its environment impact is longer negligible. Uh, just, uh, Data centers consume about around 1 to 2% of global electricity, and this is projected to rise sharply in the coming years. So, despite optimizations for cost and performance, cloud infrastructure, especially serverless platforms, is now not carbon neutral. This growing footprint motivates the need to rethink how serverless workloads are scheduled from a sustainable perspective. So, uh, uh, this is our problem analysis. Now, what we analyzed, the problem was a key factor influencing cloud emissions is grid carbon intensity, which measures how much carbon dioxide (CO2) is emitted per unit of electricity generated. So, as shown here, carbon intensity varies significantly across regions. Even within India, we have taken 4 regions here. We see 800 grams of carbon dioxide per kilowatt operate on much cleaner and function can have vastly different carbon footprints depending on where it's run. Now, this brings me to our problem statement and the research gaps that we found. Um, Although some carbon aware scheduling approaches exist, most of them focus only upon operational electricity consumption. However, embodied carbon from hardware manufacturing can account for up to 45% of the total node or oversimplified. Additionally, prior research reports conflicting results uh, embodied aware scheduling works well in low carbon European grids, but underperforms in high carbon regions like Asia. So basically, what we're trying to explain is in Asia, uh, the grids take a lot of power energy and compared to all these European grids. So that's why we've tried to propose a framework or we have suggested two algorithms as well, which will help in reducing this carbon footprint intensity. So this also creates a need for clear threshold-based guidance for sustainable serverless scheduling. Some of the gaps we found were no clear carbon intensity threshold for strategy selection, uh, hardware aging affects unrealistic done on this area, and limited validation high carbon grids. So this is the dataset that you use. This is an online open source dataset by Electricity Maps. So now let me just take you through the main methodology that we have used in our project. So to address this problem, we built a lifecycle aware carbon model. Operational carbon is calculated using real-time. Wait, I'm so sorry. So, uh, operational carbon and embodied carbon. These are the two types of carbon emissions that we have analyzed from a grid, which is using which is which servers are using. So, operational carbon is calculated using real-time regional carbon intensity data obtained via the electricity mass API, whereas embodied carbon is estimated using component-wise life cycle assessment across CPUs, GPUs, memory, and storage, and it is over a realistic 5-year hardware lifetime, while accounting for operational age. So this allowed us to capture both short-term and long-term carbon impacts. Uh, Let me just take you to the main methodology now. So the main methodology, uh, so we begin by simulating realistic serverless workloads with diverse we collect telemetry data such as CPU usage, memory consumption, and execution time. These metrics then are converted into carbon emissions by combining operational emissions with embodied emissions. So basically, we are taking data from each of these data centers, much carbon intensity each and every data center is releasing. Then, based on these estimates, we then evaluated three scheduling strategies. One is a baseline fixed approach, one is a relative carbon aware scheduler, and one is a predictive carbon scheduler using ML. Finally, we perform large-scale evaluations across multiple regions. So these are the main two ML models that we have used for scheduling strategies. One is linear regression, and the other is LSTM, long short-term memory. Now, for predicting scheduling, we employ two lightweight machine learning models. These models forecast near-term carbon intensity using historical grid data, enabling proactive workload placement rather than purely reactive decisions. It's also important to note that ML here is an enabler. The key contribution lies in understanding when predictive or reactive scheduling is actually beneficial. So these are some of the graphs that we have found in our research. So the first one, we observe a carbon intensity across at approximately 332 grams of carbon dioxide per kilowatt hour. So below this value, embodied aware scheduling can reduce emissions. Above it, operational only. So these are the two scheduling algorithms that we have designed. One is the embodied carbon aware scheduling, and the other is the operational only optimization scheduling. So by research, we have found out that 332 grams. So what we are doing is below that threshold point, we'll be using embodied aware scheduling, and above that, we are using operational uh, scheduling algorithm. These are some more stats. Mm, this is duration independence and regional insights. Uh, this, yeah. Now, another key insight is during our is duration independence. While absolute emissions increase with task duration, the relative performance difference between scheduling strategies remain constant. So this simplifies scheduling decisions. Now, as we can see here, that these are the four regions that which we have taken. So uh, this blue symbolizes embodied prioritize, whereas after the threshold point, we have used our balanced scheduler, which will reduce the emissions as we can see in the graph, it has reduced the carbon intensity emissions. These are some plots that we have found when we've used our LSTM and linear regression models. The finally what we have concluded from our project is a dual threshold framework, which has not been proposed anywhere. This is the first time which have this is a novelty which we have completely worked on upon ourselves. This also explains why embodied aware schedules only work in extreme clean grids, which always slow the aging of hardware. Full life cycle carbon integration. We have combined operational as well as embodied carbon using accurate life cycle assessment, and we have used several ML models. And the two we have proposed this framework for a lesser carbon intensity emission and for a greener planet. That's all. Thank you. Any questions from the panel? Hello?
Yes, sir.
Yes.
Ma'am, would you like to ask any question?
Yeah. Can you tell me that you are doing the carbon intensity forecast, right?
Yes, ma'am.
So means, and based on that, you are doing the scheduling decisions.
Yes, ma'am.
So if there is a prediction error in your intensity for carbon intensity forecast, so will it impact the scheduling decision accordingly? And what
Ma'am,
care you have taken for that?
yes, ma'am. So, you saying that the first of all, we've all they will cross-check these data. We are cross-checking these data. Will let's say even though a range of a certain value, let's say it's 1 to 10, if it's coming say 100, then we're of course ignoring that. We'll say that it's an outlier and we're not taking that prediction. So when we're taking the inputs only, we're putting a filter so that it'll only take like valid values, and these values only will be used to
So
calculate the
you are
carbon
saying
density.
about the range of the values which you have used here.
Yes, ma'am. Yes, ma'am. So for each and every this thing, what do you call metric, we have defined certain values, ma'am.
Can you basically, as it is a cloud basically, so can
Yes.
your approach be integrated with the existing like AWS Lambda Azure? So can we integrate with it? Is it something different?
Yes, ma'am. We can integrate this. So AWS Lambda, everything they use these models and they have a very rigorous structure, but then at the same time they don't focus mainly upon the regional intensities and workload based modeling. So even though I have a good architecture, I feel if we integrate this, it'll be a much more stronger uh, architecture.
Okay. Yes, ma'am. We can start with the other one.
Okay, thank you, ma'am.
Hello.
Sure, ma'am. Thank you, sir. We'll be proceeding ahead with our next presenter. I'd like to call upon, we have Jaya Kumar EP with the paper title DHT-MF High Quality Decision Based Half Trimmed Mean Filter Architecture for Removal of Salt and Pepper Noise. Sir, if you're ready, then you may start your presentation.
Yeah, thank you.
Yeah.
Am I audible?
Yes, sir, you're audible.
Yeah, let me share my presentation. Is my slide visible?
Yes, sir, it is visible.
Thank you. I'm Dr. Jayakumar P, Assistant Professor in Department of EC and IT Calicut, Kerala. And my co-author is Venkata Shiva, research scholar working under me. The paper title is DHTMF High Quality Decision Based Half Trimmed Median Filter Architecture for Removal of Salt and Pepper Noise. This is the outline of the presentation. To begin with, in the digital era, images plays a crucial role in various applications, right from consumer electronics to medical imaging, as well as for surveillance and many other applications. In image, especially, noises plays a crucial role while we are doing the image processing through the image processing pipeline. Noises affect our images mainly in two scenarios, that is while transmitting an image due to channel interference and atmospheric disturbances. And the main kind of noise that we encounter is called as salt and pepper noise. And noise affects the images during the acquisition process also. And this may be due to image sensor imperfections. Now, processing these images and to remove the noise is a very crucial step in the entire image processing pipeline. Now, we have done a sort of a literature review, and we identified that median filters are used to remove salt and pepper noise. And standard median filter modifies both the noisy as well as noise-free pixels, which might end up in a blurred image. Now, to avoid the changes done on noise-free pixels, usually the noisy pixels are to be identified, and then the median filter is applied selectively. Now, we have come across a couple of interesting research papers in the literature, in addition to various other papers that we have reviewed. So, in the first one, which is DPADMF, a 3x3 window is used to process a pixel. If the processing pixel exhibits noise, it adjusts the window size to 5x5. So it begins with a 3x3 window, and it adjusts the window size to 5x window. And as usual, it finds out or figures out the median values, and these kind of computation results in increased number of line buffers, and it increases the hardware cost. Another one which uses a singular value decomposition to detect the salt and pepper noise. Once the noise is detected, an alpha trimmed mean filter is initially applied, and this is followed by a standard median filter. Now, this again increases the intermediate memory, which in turn increases the hardware cost. Now, what we are proposing is we are trying to design a high quality, low cost mean filter architecture for the removal of salt and pepper noise. So this is the flow chart. We initially begin with the noisy image. We take a 3x3 window with the center pixel as the processing pixel, and we look at that center pixel, whether it is 0 or 255. 0 stands for the pepper noise, and 255 represent the salt noise. That means if the center pixel is noisy, if it is not noisy, then we keep the pixel as such. We do not process it further. Whereas if the center pixel is noisy, then in the entire 3x3 window, we sort all the pixels in descending order, S1, S2, etc. up to S9, and we check the median value, which is represented by S5. If the median pixel value is 255, that is, if it is a pepper noise, then we replace this pixel, that is the center pixel, by taking the mean of the remaining pixels, that is S6, S7, S8 up to S9, and by trimming the first four, S1, S2, S3, and S4. Okay, so in further processing, if it is not equal to 255 and if it is equal to 0, which means it is a pepper noise, then we replace the center pixel with the mean of the first four, that is S1, S2, S3, and S4, by trimming the remaining S6, S7, S8, and S9. Now, if the median pixel is neither a salt noise or a pepper noise, then we replace the center pixel with the median value. Now, this helps in improving the total image quality. The usual literature does not trim, and in some it is trimming, but it is taking the mean or the median of median as such, which results in image quality reduction. But our method, by experiments, it has been proved that it is better than the other existing method. Now, we have validated this algorithm using MATLAB, and then we further tried to implement this, figure out the hardware architecture for implementing this. And this is the high-level block diagram of the proposed method. We have our own block DHTMF placed here, and we also have a noise detector. That means we provide the entire 3x3 window to this system, and looking at the center pixel using this noise detector, we find that whether it is a noisy pixel or a normal pixel, and if it is a If it is not a noisy pixel, then we retain the center pixel as such without processing anything. But in case if it is a noisy pixel, then we use the processed pixel using the DSTMF algorithm that I have just explained and replace the center pixel with that one. So this is the high level architecture of our proposed method. And this is the internal architecture of the salt and pepper noise detector, because we need a noise detector here which tells whether the center pixel is a noisy one or not. And that is done with the help of this combinational logic circuit. Now this is the internal architecture of the DHTMF block, decision-based half-trimmed mean filter architecture. So the input to this is the 3x3 window, and we use line buffers to process through the entire images because we process the entire image using a 3x3 window, and this line buffers helps us to provide the 3x3 window of the entire image to the architecture. Now this is done in stages, where you can see in stage 1, we have used a sorting block. We do that by performing a column sorting in the first stage, and we do the row sorting in the second stage, and followed by the final diagonal sorting done in the third stage here. So this entire block represents sorting. So once I sort this in the order S1, S2, S3, S4, S5 up to S9, the middle one, that is the S5, will represent the median of all the pixels in the window. So once we get the median value, meanwhile, we'll be computing the mean of the first 4 and the later 4, the second 4 of the 9 pixels. And again, according to the algorithm, we need to figure out whether the median value is a non-noisy pixel or a salt noisy pixel or a pepper noisy pixel. Accordingly, we use a comparator here to detect whether it is a noisy pixel or a non-noisy pixel. Based on that, we take a decision whether to replace the center pixel with the median value or the mean of the upper half or the mean of the lower half. So this is the overall architecture of the algorithm that I discussed now. Now when we did analysis of our algorithm as well as the architecture, to do that, we have taken the 8-bit gray level test image sets from the standard data set 12 and the BSD68 dataset. The test images are added with salt and pepper noise with noise density of different ranges like 10%, 20%, 30%, and 40% in MATLAB environment. And then these noisy images are used as input to the proposed as well as the existing architectures in the literature to get the denoised images, and we made a comparison. Yeah, so this slide shows the different results that are obtained by providing the same noisy input to the different algorithms existing in the literature and to our own proposed algorithm. So figure A represents the noisy image, and B to H represents different output of the different algorithms, whereas this I represents our own result, of our algorithm. And the last image represents the non-noisy original image. As you can see in various other images, you could still find certain kind of artifacts and remains of the noises, but in our image, in our output, you could find it to be closely matching with the original image. So visually, it looks fine when compared to various other methods, but we cannot just remain with that. We need to have some kind of a computing metrics to validate that our results are best. So as a standard metric, we used PSNR, that is peak signal to noise ratio, and structural similarity. These are the standard metrics which are used to compare the quality after the processing. So we have computed the PSNR values for the two datasets, the images of two datasets, set 12 as well as BST68. For various noise densities, that is 10% noise density, 20, 30, and 40, and for various methods that are existing. So you can see that the proposed method, that is our own method, has resulted in a very good value of average PSNR. Say, for example, we have got 34, and hybrid method has got only 28, and LASNR has got just 31, and so on. But you can even see some of the methods are giving better results, like 35 than our method. That is when the case when the noise density is 10%. But as the percentage or the noise density increases from 20%, 30%, and 14%, none of the existing architecture keep their performance or keep the image quality better. But whereas in our case, in our proposed method, you can see that the quality still remains high. For IMF, the average PSNR value is 19.718 here for 40% noise density. Whereas if you look at our method, it is 24, which is 5 dB more better than the existing methods. Similarly, we have observed a similar kind of trend in the case of average SSIM or structural similarity as well. And our method is giving comparable results with that of few methods, but a lot more better result when compared to some of the other methods. So this table validates in terms of SSIM as well. Now we also have implemented this hardware architecture by using Verilog HDL, and we have done the synthesis using Cadence Genus compiler by using a clock frequency of 200 megahertz. And we have tabulated the different values that we have got for gate count, area, power, critical path, maximum clock, and maximum throughput, compared it with the different architectures that are available in the literature as well. So you could see that the area that is being used by our proposed method is reasonably well within the limits, and it consumes very less power. Okay, and though the critical path delay is a little bit high when compared to various other methods, and also the maximum clock frequency is 268, which is a bit slow than many of the existing methods. And the throughput, of course, the throughput will also be in a similar fashion. Okay, so the highlight or the main advantage of our method is that it consumes less area, reasonably less area than many of the existing methods, and it consumes lesser power. I could say that the drawback or one of the limitation of our method is the performance. We are not getting as good performance as that of a few of the existing methods, but we are working on it, which is considered as the future scope of this work. To conclude, the proposed DSTMF architecture produces good denoised image quality because all of our method is giving better result than all the other existing methods. But only when it comes to the hardware architecture and the results of the hardware architecture, in some of the metrics, our method is lagging a little bit. So the proposed architecture has an area reduction of nearly 96% and 66% and 88% compared to these three methods, FM and DBADMF and hybrid method. In comparison to the modular and the CFMF, IAMF, and DBM and hybrid, the proposed architecture exhibits power consumption reductions of 47%, 38%, 31%, 96%, even 96% when compared to some of the other methods. 50% and 92%. 92%. So this is our method, and these are some of the references that we have used. And thank you.
Thank you, sir. Ma'am, would you like to ask any question?
Yes. Can you tell me, as you use the different performance metrics, so which performance metric showed the most significant improvement over it and how?
Yeah, algorithm wise, in terms of PSNR and SSIM, our method performed very well. That means in terms of image quality, once after denoising, in terms of image quality represented through the metrics PSNR and SSIM, our method performed very well when compared to all the other methods. Some of the methods were good only during the low noise density, but as the noise density increases, all the other methods kind of not performing well, but our method did perform very well in terms of PSNR and SSIM.
Okay. Have you used half-trimmed mean process here? Hello?
Yes, we have used half-trimmed mean half-trimmed
Okay.
method only.
So how you are selecting the trim threshold over there and how it is adapting it?
Yeah, trimming is done based on once after sorting it, once after getting the median value, we do the trimming based on whether the median value median that we obtain. If it is noisy, then we are doing the trimming. If it is not noisy, then we are passing the median value itself to the center pixel value. It is based on the median value. If it is noisy, then we do the trimming. If it is not noisy, then we do not do the trimming.
So noisy data means how much percentage you have considered? 40-30%, or if the noise density, suppose we are saying it is exceeding the 80%, then DHTMF behaves properly with that?
We have considered only up to 40% because most of the papers that we have seen, they have worked till 40%. Even the papers that we have compared, they worked till 40%. So in order to make a fair comparison, we have done it till 40%. Yes,
Till 40%.
and when the noise density increases, we have observed that only our proposed algorithm works better than the existing methods.
Okay, thank you.
Okay, thank you.
Thank you, sir. Thank you, ma'am. We'll be proceeding on with the next paper presenter. I'd like to call upon paper presenter Nilina Listen with the paper titled EduDel, an AI-powered educational platform for automated content extraction and assessment generation. Ma'am, if you're ready, then you may start. Yeah.
Am I audible? Yeah.
Yes, ma'am, you're audible.
Is my screen visible?
Just a second, ma'am.
Okay.
It's not visible yet, but it is loading.
Okay, I'll just, is
Yeah,
it
it is
visible now?
visible now. Yeah.
So, good afternoon. I'll be presenting our paper, EduDel, an AI-powered education platform for automated content extraction and assessment generation. So, this paper focuses on converting unstructured educational data into assessment and summarization tasks. So, this is mainly used to tackle the challenges of scalability in modern education systems. So moving on to motivation and problem statement. So one of the reasons why we chose this is because a lot of heterogeneous materials are distributed all across the web, and there's a rapid growth of digital resources and a lot of availability of educational data. But the problem remains is that most of the platforms rely on manual time-intensive processes, and there are systems which do provide solutions on specific use cases, but there is a lack of end-to-end automated understanding assessment generation system. So what is EduDel? EduDel is actually an end-to-end education pipeline which is powered by AI. So we have three types of automated assessment generation, which is MCQ, fill in the blanks, true or false. We have a content extraction with summarization feature and a chatbot, which is beneficial for educators and learners, both in formal and informal learning environments. So next, EduDel actually supports a wide range of heterogeneous input like PDF, DocX, PPT, TXT, web URLs. So the outputs are three assessment series, which is actually MCQ, fill in the blanks, true or false. And it also supports summarization and an interactive chatbot, which makes it easy to chat with your educational document. So moving forward, I would like to cover the system architecture. So the stage one is actually the ingestion of educational materials. It could include PPT, PDF documents. The different kinds of documents are actually ingested to the system. Step two is actually the cleaning and pre-processing pipeline, wherein we take the documents, we clean the particular document, and then we segment the sentences we actually find the keywords which are contextually relevant and list those sentences. And then comes the question and content generation pipeline, wherein we have three assessment generation tasks: MCQ generation, fill in the blanks, true or false. So in MCQ generation, we have used for question generation the Google Flan model, and for distractor generation, we have used a combination of BERT and WordNet models, which actually combines and gives you the MCQ results. For fill in the blanks, we have used the NLP pipeline and core CV model, and true or false also we've used the rule-based NLP model. For summarization and conversational QA, we have used the Gemini model. So then we also have a semantic representation system wherein the sentence embeddings are stored by All-Mini L6V2 model, and they are stored in ChromaDB database. They are retrieved by using cosine similarity, and this enables us to find the documents which are similar to our particular document which we have uploaded. Now, model selection rationale. So the reason why we choose a hybrid NLP plus a transformer strategy is because most of the systems which are available today are wholly based on generative AI models. So bringing in a hybrid approach would make some of the tasks where the quality of the sentences, etc., is considered important. In the case of true or false, wherein sentence parsing, grammatical coherence, stability, etc., are important, Spacey would solve that particular problem. So in the distractor generation, we have used BERT and WordNet. So BERT actually gives us a context-aware distractor generator. So then we have used WordNet. So in this case, we have also incorporated All-Mini L6V2, which would actually give the most suitable distractors which are generated from the combination of these two. So Google Flan T5 is actually used for the MCQ generation. So this enables us to generate the questions which is actually suitable for that particular sentence which we have actually selected. So Gemini 1.5 Flash is actually used for abstractive summarization, and we use the same model for the conversational interaction via the chatbot. Then we have the recommendation system wherein we have embedded by using All-Mini L6V2, and we are using the similarity search via cosine to find the most relevant documents. So now, moving on the evaluation strategy. So this is though it's an end-to-end pipeline, we have used the task-specific evaluation metrics. We have not focused on the overall accuracy, but we have focused on tasks one by one. So there is an independent assessment per task, and the metrics to ensure that the metrics are actually aligned with the educational quality. So some of the metrics which we've used is a question coherence, the distractor diversity, similarity, and grammatical correctness, and ROG-L for summarization. Now, this is a detailed overview of which all pipeline and evaluation metric which we've used for this particular task. So for MCQ generation, initially we use the Google Flan T5 for question generation task when we find a particular sentence. So in this, we evaluate the question coherence, and BERT and WordNet we use to generate the distractor similar to the particular answer which is intended. So we have measured the distractor diversity, similarity, and we have calculated the overall MCQ balance after incorporating this. And in the fill in the blanks, we have used a Spacey Encode Web SM, a linguistic NLP pipeline, wherein we have actually calculated the relative keyword importance and the coherence with the particular sentence and the answer predictability. In the case of true or false, we have evaluated the false statement plausibility and the answer predictability. For summarization, we have covered the ROG-L grammar and coherence. So chatbot, we have covered the semantic similarity, coverage, grammar, and the ROG-L score. So moving forward, so this is a description of the MCQ results which we had obtained. And the results across other tasks, the important results such as coherence, coverage, and semantical similarities were calculated. Now, the reason why we chose a hybrid NLP plus LLM is because if we have like a rule-based system initially, it would reduce the case of hallucination rather than relying solely on the model from the start to the end stage. So there would be improved control in the system, and this would in turn increase interpretability. So this would in turn reduce the computation overhead, and this is actually scalable across various subjects and formats. Now, as a conclusion, I would like to say that EduDel is an end-to-end educational platform wherein we've covered different kinds of tasks. So it shows reliable performance across multiple tasks and formats, and it's suitable for both informal and formal learning environments and makes the extraction of content and assessment generation easier. So talking about the future scope, we are planning to support multilingual language, and then the teacher analytics and the performance-based dashboards and speech input support is also planned to be provided. And also gamification features along with mobile deployment would actually make this a more usable application. So these are some of the references which I've used. And thank you. I would like to answer any questions if there are any.
Yes. Can you tell me which NLP model you are using here for the content extraction and summarization?
So for content extraction, initially we have the ENCODE SM model, wherein first the sentences are selected accordingly, and then based on the keyword importance, we actually so there are different assessments, right? MCQ, fill in the blanks, etc. So we actually give the number of questions. Suppose 15 questions, then the 15 most important sentences would be selected, and then we actually.
So if it is 15 more important concepts you are saying, so how you are distinction between the core concepts and suppose the supplementary content basically?
So basically, it is actually determined based on the keyword importance in that particular sentence.
Okay.
So
Means based on the keyword, it is categorizing the sentences, whether it is a core
yes.
concept or supplementary content.
Yes. So that comes under the pre-processing step. So once that is identified, depending on the task which we are focusing on, if it's assessment, it goes for that particular task. So after that, if it's MCQ generation, then we use Google Flang T5 to generate a particular question, and then distractors are generated accordingly. Fill in the blanks means a blank would be omitted based on the keyword.
And how you are ensuring that the different difficulty level balance is maintained in the generated assessment?
So actually, we haven't provided the difficulty level option. So for distractor, differentiability is actually maintained as an average. So basically, when we are generating the distractor in the case of MCQ level question, suppose we have a particular keyword, we will be generating the distractor by using BERT and WordNet. So we would be choosing the distractors which are kind of like not that easily guessable to that particular answer, so that the average level of difficulty is maintained.
And is your platform means are you going to make it as a cloud-based system?
We haven't. We might in future.
Okay. Okay. Thank you.
Thank you.
Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to call upon paper presenter Vivek Verma with the paper titled Embedded Systems, Natural Language Processing, Locus of Control, and Investment Behavior, a Comprehensive Integration Framework for Financial Decision Making in the Digital Age. So if you're ready, then you may start your presentation.
Yes, good afternoon. Am I audible?
Yes, sir, you're audible.
All right, let me share the screen. Is my screen visible?
Yes, sir, it is visible.
All right. So, good afternoon, everyone. I am Vivek Verma, research scholar from Graphic Era University, Dehradun. And today I would like to present my research work. The title of my research is Embedded System, Natural Language Processing, NLP, Locus of Control and Investment Behavior. So I'll be moving on with the introduction part. Let me just fix it. All right. So I'll be moving ahead with the introduction part. As we know that financial markets have changed dramatically over the past few years, There are majorly three forces behind it. First is technological inventions, then digitalization, and third is the psychological factors, which I am focusing on locus of control. I'll be talking about locus of control now. So for decades, finance was built on a simple assumption that investors basically act rationally in the market. But recent studies have shown that people tend to act. People may surprise you. The fusion of this study basically focuses on examine how the innovations in embedded systems and NLP along with the psychological factors affect the investment decision making of an individual. So we know about these factors individually, like embedded system. We know that what is an embedded system is a specialized computer system with dedicated hardware and software, basically designed to perform special functions. What is the NLP? NLP is a branch of AI that teaches computers to basically interact with the humans. And then we have locus of control as psychological factor. Basically, it is a psychological concept describing whether people believe they control their lives or some outside forces are controlling their life. So we know about these factors individually, but let's explore how they behave when put together to process the information. So as I said, I'll be covering three aspects. First is fintech, which covers embedded systems and IoT innovations. Second is psychological factors, which I'll be talking about locus of control. And third is analytical or analytics, basically, which covers advanced NLP and deep learning. So my research objectives are, first is to compile and summarize recent empirical studies on the use of NLP-based sentimental analysis in finance, in the area of finance, and assess how these applications basically helps predict investment behavior of an individual along with the market movements. My other objective is to examine the technological architecture of the embedded systems and real-time data pipelines used for large-scale sentimental monitoring in the financial markets. My third research objective basically is to investigate the psychological construct of locus of control and as a potential factor which can shape the investment behavior of an individual. And lastly, I'll be proposing one integrated model including all these factors. So this would be the roadmap of my study. As I've already said that we know about these factors individually, but how they behave when they put together to process the information. So let's talk about one by one. So first is, if we use embedded system in financial technology. So embedded systems signify a specialized computing system that are architected to perform a specific function in the larger system, generally with limitation of power consumptions, processing capacity, and real-time responsiveness. And with the NLP in financial analysis, since NLP is a part of perception system that belongs to the AI, and it basically teaches computers to interact with the humans. So how they use the data, and third is locus of control in psychological and financial context. Locus of control is a context that basically given by J.B. Rotter in 1996. It is based on the social learning theory. So let's put together all these. And first, architecture and capabilities of modern embedded financial systems. So the thing is, when any individual invests somewhere, and he or she may maybe getting the information from many sources. So how the embedded system process that information, how NLP decode that information, and how that process works basically. So it is the real time data collection and processing. Embedded system have facilitated the continuous and real time monitoring of market dynamics via distributed sensor networks. So the system collects multiple data streams simultaneously: transaction data from trading websites or trading platforms, textual data from news feeds and social media, and proprietary data from the market participants. So real-time processing capabilities allow for the detection of anomalies, regulatory compliance monitoring, and fraud identification at once. Also, when we integrate this AI with advanced analytics, then embedded system with machine learning capabilities can instantly perform sentiment analysis of the incoming text streams, and they can produce real-time anomaly scores for fraud detection. And also, the real power of embedded system in financial applications comes from their integration with AI. That is the core, basically. The machine learning, like Edge AI, for example, the implementation of AI models right on the edge devices has become the key technology in 2024. It has predicted 76% accurate data for Bitcoins and for other cryptocurrencies. So, evaluation of NLP techniques in finance, how it happened. NLP in finance has gone through different generations of technological changes. So the first generation NLP in finance used word like positive, negative, and neutral. There were limitation for the technology, but after some models like BERT model, then it allows the use or determination of the meanings of the word in the full context. Like uh, if we take an example like bear word basically represents the market decline rather than an animal. So this is how the NLP picks the word and uses and analyzes and uses that into predicting the financial outcomes. Large language models, LLMs, are also being used in the area of finance. Like contemporary research have been increasingly using LLM models such as ChatGPT 4 and GPT 4.0, and also some other models. And these applications are being applied to the stock market prediction and market forecasting. Empirical applications of NLPs to stock prediction shows uniform results. Research work on Bitcoin, Ethereum, and other cryptocurrencies, as I've already told, report that the fine-tuned models are able to deliver the prediction accurately of price movement and trading volumes at the significant level, with the impacts of sentimental differs from one platform to another. Across the platform, it can generate the accurate results. Now, the most important aspect of this is sentimental analysis across multiple data sources and language. This is the core part of this model. So, non-English financial sentimental analysis was a very challenging task in the past because there were no tools available. But thanks to the artificial intelligence and NLP, now the computers, the machines are learning basically to decode the keywords and predict the accurate results. So these breakthroughs put worldwide investors in a position to take advantage of sentiment analysis from the foreign language market, and they were previously hampered by the scant NLP coverage. There were limited keywords there. And now the third part. Now, the uniqueness of this model is to add the psychological factor. I am taking locus of control, which basically decides the investment decision making. So empirical research has consistently shown that those investors who had a more internal locus of control. So one kind of people are there who thinks they are in control of their life, and others are other things that there are some other factors. There are some external forces like fate and luck are controlling their lives. So those who have their internal locus of control high were able to critically evaluate information. Lots of studies in this regard have shown these results. And risk perception is also similar in this regard because some investors are the risk takers. So it is an important factor. So risk perception is also similar in this regard. People who consider themselves able to handle risk uh, will make different investment decisions from obviously who are conservative. In fact, control over one's own life also shows that it can have a direct impact on individuals' decision apart from its mediating role, which means that there are both mediation, like this locus of control can be a mediator and can be an independent variable as well. So it can have a bias effects. The research on loss aversion and regret aversion, overconfidence and herding has found that the locus of control affect the extent to which cognitive biases actually lead to investment behavior. Behavioral research on locus of control as a moderator of biases, which pointed out that while cognitively biased individual with both internal and external locus of control are in the same situation, In fact, those with external locus of control shows stronger behavior manifestation of these biases. Now, if we integrate this psychological factor with the technological factor, so the digital world and robo advisors have introduced technological mediation. Hence, the investors have external locus of control may demonstrate higher trust in algorithm because they think that outside forces are controlling their life. On the contrary, cognitions of internal locus of control can lead to a firm stance against such systems and may even result in overestimation of their personal analysis. It happens. People don't behave rationally in the market. The incorporation of behavioral finance concept into fintech platform is a new horizon to be explored, which this study basically um, presents, or basically this model I am proposing. So this is the conceptual model or integrated model that I'm proposing. So taking data from market and investors and then let it process through embedded system and advanced AI enabled systems. What system will do using NLP and sentiment analysis, it would interpret the sentiment and financial information, then it can lead to the financial decision making process because it would give us some result where the market is going and all those things. So therefore, this is the model, and here locus of control I'm taking as the mediator variable because a locus of control basically decides the human factor here. And uh, after like I am about to test this model for the larger information as well now. So I'll be concluding this like we can see recently a large body of evidence have been collected and that demonstrate the integrated framework is needed a powerful tool in prediction. That's why this model. For example, machine learning models enhance with sentiment can forecast the stock prediction as we have seen 76% accuracy predicting the price, predicting the value of the cryptocurrencies. So I think sky is the limit in this area. So basically, embedded system enables real-time financial monitoring. That is the first takeaway. NLP transform the sentiment analysis capabilities. Locus of control can mediate the technological impacts, and integrated models advances behavioral financial research. These are the key takeaways. The contribution of my research would be it would bridge technology, psychology, and finance domain. It would provide one integrated platform and also, it would provide empirical framework for LOC moderation effects. It would advance the financial inclusion through understanding the financial concepts, and it would inform the next gen fintech product design. Like this is basically a product idea I'm in the stage of developing. In future, as I've already mentioned, that this model can be validated through the empirical research, empirical more and more empirical studies conducted so far by the other authors after 2025. Development of investor advisory system, that would be the final product, and integration of metaverse can be done, and it can be used as a tool for the financial inclusion program as well. So thank you. That would be all from my side. Thank you so much for giving me the opportunity to present my work here. Thank you.
Can you please tell me the novelty of integrating the locus of control with embedded system NLP for financial decision making specifically? What, as we have studied too many things there, basically it is a literature survey paper. So what novelty you find over here of integrating?
So in this model, the novel factor would be the NLP, basically. Earlier, uh, no such tools were available with us to decode the advanced keywords which are being used as of now. So this model would consider the advanced level NLPs. Like we know already like NLP have the technology have advanced now. So the novelty of this model would be the using the NLP here.
So,
predict the.
the other models which are existing, like fintech, many financial recommendation systems are there. So, they are not using, you mean to say, these all?
Not at this level, and it is the unique integration of the embedded system as well. Like they are not using
Okay.
any, they are just using the NLP and also the LOC, the locus of control, the psychological factor would be the one, the unique part of this model.
So, you are saying that locus of control you are using, but how you are ensuring the reliability and validity of that psychological uh, measurement basically?
So what we are proposing is to get a questionnaire filled, get a basically the questionnaire provided by the scale provided by the many authors and validated by many authors. Then on the basis of that questionnaire, like that would be for one time exercise, and then on the basis of that response, the system would do a profiling of the investor.
Okay.
Yeah.
Okay, that's all from us. Thank you.
Thank you, sir.
Thank
Thank
you.
you, ma'am. We'll be proceeding ahead with our next paper presentation. I'd like to call upon Parvati Suresh Kumar with the paper titled Interactive Sentiment Analysis of Policy Discourse from Video Using RLHF and LLMs. Ma'am, if you're ready, then you may start with your presentation.
Hello,
Yeah, ma'am.
am I audible?
Yes, ma'am, you're audible.
I am Parvati Suresh Kumar, fourth year student from Amrita Vishwavidyapeetham. I am presenting the paper Interactive Sentiment Analysis of Policy Disclosure from Video using RLHF and LLMs. Currently, while the financial policy announcements have written analysis, a lot of nuances and opinions are usually lost as the most important opinions from the local population. Therefore, the public sentiment is mainly delivered by YouTube videos, budget speeches, and expert panel discussions. Therefore, the challenge arises when we try to extract accurate sentiment and insights from unstructured video content, as the current systems work mainly on textual data and fail to interpret domain specific spoken media. This was what we sought to solve. Hence, these were our research objectives. Developing a video-based sentiment analysis system specifically for financial and policy-related content, enabling context-aware question answering from uploaded content and videos, adapting LLMs to financial and governance domain, designing a scalable memory efficient deployment architecture, and finally, incorporating human feedback so as to continuously improving the quality of the response. So this is our system architecture where the first step is to input a video. It can either be a YouTube link or an upload from the local device. Then the audio is transcribed and so the context in the text is in the text form. Then text will be embedded and then stored in ChromaDB, which is a vector store. So it can be retrieved later for the context. The retrieval will be done using RAG module over here, and the feedback will be given here using the thumbs up or thumbs out button. And the user interface will be a chatbot where the users can ask anything about the uploaded videos or general questions on the financial policies. So the audio processing and transcription was done like this. First, the by YouTube DLP is used to download the YouTube videos. When it is given as a URL, FFmpeg was then used to extract the audio. Then the audio was converted into text using Whisper so that also handles the translation. if the language is not English. So in that case, it first translates and then it transcribes it. If the video is very long, it then breaks into smaller parts and then does this part for each. In the end, we get clean, searchable transcript that can be used for both sentiment analysis as well as for context retrieval. For the RAG part, the transcripts are chunked and then embedded using mini LM embeddings and then stored in ChromaDB. This is how it goes. The user query is embedded. Then the cosine similarity is used to retrieve relevant transcript chunks. This retrieved context is then passed into the LLM for answer generation. We use this to reduce the hallucination and to improve the accuracy. So for the methodology part, we have used base model Llama 3.21b instruct as the base model for fine-tuning and has used LoRa for efficiently doing it, where the base model weights are frozen and only the LoRa adapters are trained. This was implemented using Unsort. This ensured that domain-specific sentiment was understood while achieving lower memory and compute cost. The RLHF was integrated for improving the quality of the responses. The feedback was collected using thumbs up or thumbs down, and this was being used as a reward signal. We use BERT-based reward model that evaluates relevance, sentiment correctness, contextual alignment for the response to improve the response quality over time while enabling continuous learning. So coming to novelty, the main novelty is that this is an end-to-end system that combines video-based system sentiment analysis, RAG-enabled answering, and LoRa-based fine-tuning, while supporting multilingual videos, which are actually necessary for an accurate public sentiment. YouTube links and direct uploads can also be supported. LoRa adapters helped us with the task, reuse and scalable deployment. Hence, this let us move beyond the comment-based sentiment analysis and helped us focus on the speaker intent and the policy tone. So the findings are as follows. We saw improved content accuracy after implementing RAG by effectively inferring the sentiment from the budget speeches and financial announcements. LoRa fine-tuning let us achieve strong domain adaptation by reducing storage and inference movement. This can help policymakers understand the public and expert sentiment while helping the economists and analysts understand the financial tone and sentiment. Citizens can understand the budget speeches and their complex terms easily, while media organizations can use automated analysis on the financial disclosure. Hence, in conclusion, this project was successfully able to bridge the gap between video and sentiment-driven insights in scalable, modular, and user-friendly chatbot system. In the future interactions, the following can be done. Hierarchical retrieval longer videos using QLoRa for further memory optimization, using an automated reward modeling by using more advanced LLMs and improved transcription correction for financial tech terminology. With this, we end this presentation and we are open to questions. Thank you.
Can you tell me that how your approach is improving upon text-only sentiment analysis methods for policy discourse.
So when we're using YouTube videos or many other audio and everything together, we'll be able to get the more public sentiment.
Okay, and how
So
you are
we
fusing these all the things together in your sentiment analysis pipeline? Video, audio, and textual also you are fusing all these things, right?
yes.
So how you are fusing these all things in your sentiment analysis pipeline? There must be a pipeline, right?
I'm sorry, could you please repeat?
So I'm asking, as you are using the video, audio, textual also for sentiment analysis, right?
The
So
Whisper
how
and AR will be changing the text and video, everything will be clubbed in together.
okay, thank you.
Thank you, ma'am. We'll be proceeding with our next paper presenter. I'd like to call upon paper presenter Parvati Suresh Kumar with the paper titled Interactive Sentiment Analysis of Policy Discourse from Video Using... sorry, ma'am. You just completed the presentation, right?
Yes.
Yes, she has
Yeah, I'm
completed
so
just
sorry.
now.
Yeah, I'm so sorry. We have Niladri Majumdar, but their co-author is gonna present the paper, Swamjit Saha, with the paper titled Knowledge-Aware Self-Correction in Language Models via Structured Memory Graphs. So if you're ready, then you may start with your presentation.
Yes, sure.
Yeah.
Is my screen visible?
Yes, sir, it is visible.
Okay, awesome. Just- All right. Hello, everyone. I'm Swamjit Saha. So I'm affiliated with Mississippi State University, where I'm a computer science PhD student. So my other co-authors for this paper are Shubhobrata Das, Devansh Sangani, Oritra Chakraborty, and Niladri Majumdar. So today, Niladri had a network problem, so I'm presenting on his behalf. Our paper title is Knowledge-Aware Self-Correction in Language Models via Structured Memory Graphs. So the problem is that LLMs are fluent, as we all know, but it can hallucinate facts. So our goal for the paper is to add a lightweight correction layer that improves factuality without retraining the base model. So let's get started. And let's see, why do we need self-correction in the first case? So as we all know that even strong LLMs exist in nature, and it can produce confident but wrong factual claims, which is like very risky in domains like education, or it may be science, legal, and technical writing. Although the good news is that there exists solutions like RAG, which does help, but they add complexity and may still return inconsistent outputs. So we focus on a simpler idea by keeping the LLM for fluency and use an explicit knowledge store for fact-checking and correction. So the core idea is basically to separate fluency from factuality. So talking more about the core idea, basically, we do decoupling responsibilities. That is, in the first case, the large language model generates language via an RDF knowledge graph, and it provides ground truth for specific relations. After the model responds, we extract candidate factual claims and verify them against the RDF graph. If a contradiction is detected somehow, the graph has that correct fact, and we make a minimal edit to fix only the wrong span. Now, I will try to show the system architecture. So this is our system architecture. This diagram summarizes the workflow that there is a user prompt which goes inside the digital GPT-2, which is our model. And this digital GPT-2 is correspondingly generating a response. And it has this correction layer which checks against the RDF knowledge graph. The correction layer here acts as a post-processing module, so it's model agnostic. And most importantly, the knowledge graph is auditable. So anyone can trace exactly which triple supported the correction. Next, I will try to show the step-by-step pipeline for our experiment. Sorry. Yeah. So we follow a simple pipeline here. The first is we generate a response. Second, we extract entity, that is the relation pairs. Then basically the third component in our pipeline is the query RDF triplet. Four is the validation phase. And fifth is we replace the incorrect object with the correct one. And it is also important to note that if evidence is missing, we do nothing. We do keep the original output, and that's how we safeguard the fallback policy. So our system is conservative. It only corrects when it can prove the correction. All right. Now going on to the structured memory as RDF triples. Our memory is an RDF graph of triples. That is, it has the components subject, predicate, and object. For example, the example of a triple can be like Eiffel Tower. Like if you see, Eiffel Tower has location, comma, Paris. So we implement this RDF lib library, which makes querying deterministic and explainable. The benefit from this is basically transparency. Unlike hidden parameters, the knowledge is explicit and extendable. So now the question arises, like, what does the correction step actually do? So here we talk about the correction layer. The correction layer aims for localized edits. We don't regenerate the whole answer. For example, let's say the user gives a prompt like Eiffel Tower is located in London. We check the RDF and find the correct triple that it is in Paris. So basically, the LLM will now regenerate the prompt with the Eiffel Tower is located in Paris. And that is how fluency is largely preserved here. The algorithm sketch is briefly narrated in the left-hand corner if anybody wants to take a look. Next, I will try to describe the experimental setup that we use to test this. All right. So as again, our base model was digital GPT-2. For our experiment, we curated an RDF memory graph with factual triples across categories like geography, history, science, etc. We evaluated on near about 20 factual prompts and measured how often the model is wrong, also like how often we can correct, as well as whether fluency is preserved, or also about like correction latency. We also ran an ablation study where we removed 25% of triples to simulate incomplete knowledge. Now I will talk about the results, starting with the accuracy. Yeah, this is the results for our experiment. It shows the factual accuracy. So out of 20 prompts, our distill GPT-2 produced 7 incorrect factual outputs. When the corresponding fact existed in our RDF, we corrected all 7. So that means like 100% correction. A few representative fixes that we did is like, the Eiffel Tower, the classic Eiffel Tower location example that I was like talking about previously. Then the World War II end year. Then we also like, tested on what is the boiling point. Then who was the builder of Taj Mahal? So these were the representative fixes that were in our prompts. So a key message from our accuracy is that the layer is effective when the RDF graph contains the needed grounding, but the correction shouldn't ruin fluency or be slow. So next we talked about the fluency or the latency. In our experiment, latency is low. That's why corrections happen in under near about 500 milliseconds on CPU. And we also see that fluency retention is strong because we only edit a small span. In our cases, 6 out of 7 corrected responses retain full fluency, so no awkward grammar after replacement. And the approach is quite practical for real-time settings. Next, I'm talking about the robustness of this experiment and the error cases that we incurred. So the first that I would like to say is the ablation. Removing 25% of the triples simulates missing knowledge. When the graph lacked the relevant triple, we don't force a correction. We keep the model output to avoid introducing new errors. We limited the we yeah so so we try to test one scenario where there was entity normalization, such as like I don't think the example is here. All right. All right. Yeah. So I will just try to see. Yeah. So somehow the point, I think it got deleted, but yeah. So I was talking about entity normalization. So there were like alias dictionaries, such as like OWL, same as links. And we we tried to incorporate the Wikidata style entity resolution, and that's where we incurred entity normalization there. So this was the error case. So as far as our conclusion, basically we proposed a lightweight, auditable self-correction layer using RDF memory graph. The main takeaway from our experiment is obviously the post hoc factual correction without retraining, which makes the whole setup very simple and interpretable. We do demonstrate strong correction performance when knowledge exists with very low latency and mostly with preserved fluency. As a next step for researchers, I think robust entity linking or aliasing is a major avenue to look into. And handling more complex sentence structures, we did try to run simple prompts like where the Eiffel Tower is located in Paris. So this could be leveraged to much more stronger prompts or more complex sentence structures. Then obviously the third scope could be to scale this knowledge graph and benchmarking against other lightweight RAG baselines. Thank you. And yeah, I would be happy to take any questions from the judges.
Yes. Can you tell me the advantage of using the RDF triples over an unstructured embedding for, say, self-learning or self-correction in LLMs, as you are using the RDF triples?
Yeah, sure. So the advantage is basically like it's a lightweight model. So we try to incorporate uh, the RDF triple idea with the digital GPT-2 model, so which is like a very lightweight model. So I think that's the main advantage.
Okay, do you know how RDF triples maintain the explicit semantic relationship during the correction process you have used your new system? How it maintains that explicit semantic relationship?
I would love to look more onto this and come back.
And what type of knowledge you are encoding as RDF triples here? Factual or procedural or relational, basically?
This was factual.
Factual. Okay. Thank you.
You're
Thank you,
welcome.
sir. Thank you, ma'am. I'd like to proceed ahead with our next paper presenter. We have Akshak Sharma with the paper titled Negative Capacitance Field Effect Transistor, a comprehensive review of materials design and applications. So if you're ready, then you may start with the presentation. So you seemingly you have an issue with the presentation, so we'll move on with the next presenter, and then you can present later on. Our next presenter, we have Vaishnavi Kustagi with the paper titled Prediction of Caesarean and Non-Caesarean Deliveries Using Machine Learning Models, Performance Evaluation and Discussion. Ma'am, if you're ready, then you may start with the presentation. Ma'am Vaishnavi? She's not seemingly with us in the meeting yet. Our next presenter, Sir Ramu, with the paper titled Sensor-Driven Fault Intelligence and Predictive Reliability Enhancement in Active Distribution Networks.
Yeah, good evening. Can you hear me?
Yes, sir, you're audible.
Yeah. I'll just share my presentation.
Sure, sir.
Is my screen visible?
Yes, sir, it is visible.
Uh, is it clear? My screen is clear, right?
Yes, sir, it is clear.
Yeah. Uh, Good evening to all. I would be speaking about sensor-driven fault intelligence and predictive reliability enhancement in active distribution network. This is paper number 692, and we have our co-authors, Dr. K. N. Dinesh Babu, who's from Power System Protection from Mega, and Mr. Yogesh Shah, who is a power sector specialist from PwC, and I'm Ramu Ravichander, General Manager from Mega. Today we'll talk about the distribution network challenges. What are the regulatory authorities, how they measure the distributor and distribution network performances, and what are the challenges they face, and how do they mitigate, and what are the solutions available. So this is a diagram shows a modern distribution network with multiple areas, grids. You can see area 1, area 2, and area 3 are all load areas. It's a modern distribution network with bidirectional current flows. Unlike traditional radial feeders, power can flow from multiple sources due to embedded generation and micrologic controls by MGCCs. Relays and fault locators are installed only on selective locations in such a grid. Not every bus are lateral. When a fault occurs, especially in sections without relays, conventional fault location becomes a big struggle due to this changing network topology and multiple in feeds. So, if you see in a conventional system, there are relays and fault locators which are installed, and the current flow would be unidirectional, so it becomes easy for fault location. In complex distribution systems, relays are not present everywhere. Fault location locators give wrong distance, multiple possible locations, no result at all. As a consequence, what happens is long fault patrol, trial and error isolation, high SAIDI and SAFE. Uh, uh, Also, the regulators who measure or evaluate a distribution network through SAIDI and SAFE. Uh, if we go into the SAIDI and SAFE, what the SAIDI says and what the SAFE says. So this is the system average interruption duration index. It's a reliability indicator used by power utilities to measure the average outage duration of for each customer served. In utilities, we have just taken one example here, assuming 1,000 customers, total duration of all customers interruptions in a year is 10,000 minutes. The SAIDI would be 10,000 minutes divided by 1,000 customers is equal to 10 minutes per customer. So just an example what we are saying, and this is too high when you calculate the number of customers or the complex distribution areas. This is too high, and this normally would not be acceptable. Uh, so SAFE, System Average Interruption Frequency Index. This measures the average number of interruptions that a customer experiences over a specific period. It helps utilities identify weak spots in distribution system and prioritize maintenance and upgrades to reduce the frequency of outages. So we take some example. If a utility serves 1,000 customers and there are 500 interruptions in a year, the SAFE would look like this. 500 interruptions divided by 1,000 customers is zero point 0.5 interruption per customer. This means that on average, each customer experiences zero point 0.5 interruptions during a year. So this, if you relate it to huge customer base, this again is a problem. So there are solutions to mitigate this kind of challenges, and also to ensure the regulators are giving you reward for maintaining a grid effectively, managing a grid effectively. So MS 5000, a sensor-based solution, online sensors, which has three sensors put on R, Y, and B, where one of them is called as the master and the other two are called as the slaves. And this operates on a GSM-based network. It has an inbuilt SIM, and we also create an IP mesh radio within our software, and the datas are collected through a gateway router, and this in turn is integrated to the SCADA. So you get all the informations sitting in your control room, the entire distribution network, and even if there is no network, if there is no mobile network. So we have a system called as MS3010 cellular gateway. So this actually collects the data from the area, from the sensors where there is no network, and in turn it communicates with our gateway router, and data is sent into the SCADA, and the user can get all the data in case even there is no network. So these are various outputs of system, what it gives, the fault location, the waveform, the daily trends, the heat maps. Here, what this does is it measures current, it measures voltage, it measures fault current, it saves the waveforms, it takes the event time with the event time stamps. It sends the data to the analytics platform. Fault location becomes completely data driven. It is not just an assumption. It becomes completely data driven, and you can see the dashboards over a period of time. With the real time, you can see what are all the events captured. It gives as a summary, and finally it gives a heat map. So you can see it's a single line diagram of the distribution network we have shown here. So you can see some areas where it is marked in red. So those areas are problematic areas, and whereas the green and the yellow areas are uh, non-problematic, or the network, the grid is functioning effectively. So the weak spot identification is given here. You see the network more clearly, and you can see the red network area where the sensors are installed. It is picking up and it is giving a heat map. So this will clearly give an idea to the distribution network maintenance team. They can go to the right areas and they can do the fault analysis, and they can restore the grid in a very shorter time. So finally, it is going to improve the SAIDI and SAFE and the grid availability, or the power availability, and in terms of revenue also to the distribution company. It matters a lot, because every power transfer time lost is revenue lost to the distribution company. And of course, it is also going to disturb the consumers, where they will suffer without power, and they will go for alternate power generation locally. So this also captures various data like weather data and harmonic spectrum, and you can see the weather data, wind speed it records the wind speed, it records the direction, and it also gives the information of moisture or rain, or you can say some structure fallen on the grid, maybe in a highly vegetation area, the trees would have fallen on the network on the uh, RYB phases. So it captures everything and it also gives the harmonic spectrum with respect to the nonlinear load pattern it records and also the statistical chart. So the conclusion is identification of fault location helps in faster restoration and downtime, reduction of SAIDI and SAFE. Challenges in conventional protection system is addressed using this site-mounted sensors. Thank you.
Thank you, sir. Ma'am, would you like to ask any question?
Yes. Can you tell me how your method is improving upon the traditional protection on fault detection systems?
Yeah, I have my colleague Mr. Dinesh Babu, Dr. Dinesh Babu also. Dinesh, are
Yeah,
you
I
available? Yeah.
hope I'm audible. Ma'am, thanks for the
Yes,
question.
yes.
In the
Mm.
traditional system, the relays are installed in the substations. It
Mm.
cannot be installed directly on the transmission line everywhere because the numerical relays are like a computer and it is safely placed in a environment with air conditioner. Whereas this is a IP67 device, we can even pour water when the current is flowing in it. So it can be mounted directly on the overhead line in the field. So that's the biggest advantage of this products and the solution compared to the traditional protection algorithms.
Okay. Okay. And how you are differentiating between the normal load variation and the fault conditions in your through your system?
By the study of the symmetrical components. So during the normal radiation, the positive and negative sequence, the positive sequence will increase, but the negative and zero sequence difference would not be much in a three-phase system. Whereas in a fault condition, we have a huge unbalance in the system with harmonics also.
And how you are handling that sensor noise latency?
We have the filters inside this equipment, and currently we are using this as a monitoring equipment. So it's not a replacement for a relay. It will give us the fault location and other information for analysis, like the weather correlation, which Ramu was sharing during the presentation. So the user can identify which area would be more prone to fault when a rain occurs in future or if there is a wind, so that the uh, maintenance team can be made available for that region to immediately rectify the fault. So here we are not preventing the fault. The moment the fault occurs, we can act very fast to rectify the fault. So that is the main intention of this solution.
Okay, so you are saying that how fast you are responding to it. So if we can your system propose system operate in real time?
Yeah, this is real time.
Yes.
What we have. Yeah, please, Ramu, go ahead.
Yeah,
And
yeah,
what
it's
will
a
be the
real.
response time for that?
Here we are operating at 80 samples per cycle. So it is equivalent to what the IEC 61850 standard of protection system has defined. So this can actually do the work in similar lines to what the relay can do. So we can identify a fault in two cycles, that is 40 milliseconds in a traditional 50 hertz system. But the only difference is we are not tripping the breaker directly like what a relay is doing. We are just identifying the information and we are even generating the oscillograph files in CFG format that is complied to the IEEE C37.111, which we can even replay and do a complete analysis in RTDS systems.
Okay. Okay. Fine. Thank you.
Thank you. Thank you,
Thank
ma'am.
you.
Thank you, Dinesh.
Thank you, Ramu. Thank you all.
Thank you, sir. I'd like to call upon our next presenter. We have Sir Gunjan Sonar with the paper titled Analytical Study Green Building Materials and Lead Ratings. So if you're ready, then you may start with the presentation. Sir Gunjan. So, Gunjan, if you're ready, then you may start with the presentation. It seems he has a issue. I'd like to once again call for Sir Akshak Sharma. If you're ready, then you may start with the presentation.
Ma'am, are you able to see my screen, ma'am?
Yes, sir. Your screen is visible.
Uh, so, good evening, everyone. My name is Akshay Sharma. Currently, I am pursuing my master's in Manipal University, Jaipur, and my co-authors are Mr. Amit Rathi, Mrs. Shilpi Bella, Mrs. Neha Singh, Mrs. Sonam Kaur, Mr. Amit Kumar Goyal, and Mr. Arun Kishore Jawhar. So, my paper is a review paper. It is a comprehensive review on negative capacitance field effect transistor. It's what are the materials used and what are its design and its application in a semiconductor field. So, what is the motivation for doing a review in this particular device? So, in general, MOSFETs, we have a typical threshold. There is a limit called Boltzmann limit, in which there is a all the conventional MOSFETs are limited by minimum subthreshold swing of 60 millivolt per decade at room temperature. So what are the effect of this limit actually restricts further restriction of supply voltage, leading to increased power consumption in advanced CMOS technologies. So because of this limit, we cannot reduce the size of the MOSFET, because if we reduce the size of the MOSFET, because of this limit, we will have to give there will be reduction in supply voltage, and in there will be reduction in efficiency. So for this problem, we have done our review on NC we have done our review on CFET, and it has provided a solution for this problem. So NCFET offers a pathway to sub 60 millivolt decade, enabling low power VDD and significant energy saving. Um, and also this device has shown compatibility with CMOS process, with especially with HF2 based ferroelectronics. So our main goal for using NCFET is to develop ultra low power electronic technologies to reduce over power and energy consumption. So why we need low power consumption? Because approximately one third of greenhouse effect is caused by electronics, and this one third of greenhouse effect is caused by transportation. Remaining is from other sources. So because of continuously increasing performance demand of electronics, so high power dissipation takes place. So because of this, we need a high effort for cooling. We need more fans for cooling the devices. It also increases operating cost. And for increasing performance, we need large batteries or large voltage sources to operate these devices. And because of these problems, this large batteries and other systems for cooling the device, the mobility of devices decreases. So before going on NCFET, we have to first understand what is the Boltzmann limit. So Boltzmann limit is a fundamental barrier set by thermal physics that determines how quickly a conventional transistor can switch from on state to on state as gate voltage changes. So as we have studied that when we apply gate voltage to a transistor, typically a MOSFET or any FET, first it goes from off state, then it goes to on state. But according to this limit, in 60 millivolt field, if we increase gate voltage by merely 60 millivolt, then there will be an increase in the current 10 times. uh, so why this limit exists? So electrons at any non-temperature have a spread of energy. As we know that electrons are always even if there is a very low temperature, there will be some energy in the electrons, as they are packed in solids, also in liquids and gases. So because of this thermal energy, even when the gate is below the threshold, every device, every MOSFET has a threshold limit. After the gate voltage is above the threshold, the MOSFET or the transistor will start conducting. Some electrons still have some energy to get across the barrier. As we know, there is a barrier. So turning the device off more sharply than this determined slope is not possible with carriers and thermonic elements. As we know that there is a we have a limit. There is a barrier, which is the threshold barrier. Because of that, because some electrons have a kinetic energy, so when we switch off the device, there will be some leakage because electrons will be still going after passing the limit. So what is 60 millivolt decade? So it means if you increase gate voltage by about 60 millivolts, the current increase by 10 times. Means if you increase a gate voltage by 60 millivolt, then there will be 10 times increase in the ID. So this limit is generally observed in a room temperature. So what will be the practical consequence of this word? So to reduce supply voltage or dynamic power, you want a steeper, so which means a smaller sub-threshold swing. Conventional MOSFETs are limited by this Boltzmann limit, so lowering operating voltage without losing performance is very hard. Now there is another term we have to understand, and that is sub-threshold swing. So sub-threshold swing measures how quickly a MOSFET turns from off state to on state when you raise the gate voltage in weak inversion region. As we have known that there are three regions: accumulation region, inversion region, and then conduction region, where a channel length that is formed. More simply, it tells you how much gate voltage is needed to make the transistor current grow by 10 times. As we have studied about that 60 millivolt decade problem. A smaller S means the transistor switches more sharply. A larger S means that it needs more voltage to change its state. A smaller S means a smaller S here will be meaning that we need very little gate voltage to on the device to change its state from off state to on state. A larger value of S will be that we need more voltage to change its state from off state to on state. So if the value of S is 60 millivolt decade, raising the gate by 60 millivolt increases the drain current by 10 times, as I have already told in that Boltzmann limit. So if we raise another by 60 millivolt, then there will be another 10 times limit. So if we apply 180 millivolt, so you will get 10 time into 10 to the power 3 times change in current, meaning 1000 times. So good switching needs small s, so you can use lower power supply voltage and waste less power. As we know that uh, if there is small s, then there will be low voltage and there will be low power losses. As we know in all devices, there are vi. If we As we know the formula of power, that p is equal to vi. So if there will be less value of v, so there will be less power losses. So if we reduce s, so what will be our results? Reduce power supply voltage, plus we will have low power dissipation, and it will improve our static noise margin, as it depends on sub threshold value. So after understanding these terms, we will have to understand what is the background and what are the evolution have taken place in this technology. So Salahuddin and Datta suggested that replacing a conventional insulating layer with a ferroelectric material could lower the energy required for switching devices. As we know that a typical MOSFET, we have a insulating layer between gate and that substrate and drain and source. So Salahuddin and Tata, they suggested that for lowering the sub-threshold swing, we have to replace that insulating layer of oxide with a ferroelectric material, so that there will be less S, and it will be easy for MOSFET to change its state from off state to on state. So their work provided the first experimental evidence of a long predicted phenomenon called negative capacitance. So, what is capacitance? As we all know, describes how a material can hold electric charge when we apply voltage is applied. So, how much charge a system a material can hold, that is defined as capacitance. And we all know, we have all studied that Q is equal to CV, where Q is the charge and C is capacitance and V is voltage. So Q is directly proportional to voltage through capacitance. So after that, after going through these early experimental demonstrations of NCFETs utilized perovskite ferroelectrics such as PB, ZRTiO3, PZT, and SRBI2 Ta2O9 SBT. But these materials pose significant integration challenges due to their incompatibility with standard CMOS processes and instability at nanometer scale. Um, as Salahuddin and Datta, they have demonstrated that it will be good if we use a ferroelectric layer instead of insulating layer for reducing the S. So different materials, ferroelectric materials were used to check if this phenomena is possible to achieve or not. So first they used perovskite ferroelectric such as mentioned in these lines, like PBZRTiO3, which is PBZT and SBT. But main problem was that they are not compatible with the MOS that CMOS we use today. So because of their incompatibility, we are not able to use that with our conventional CMOSs. But after that, for after further years, the accidental discovery of ferroelectricity in doped hafnium oxide HFF2
Excuse me, sir.
in.
I'm really sorry to interrupt you, but I'd like to remind you of the time limit.
Okay, ma'am, I will conclude fast. So basically, after using different materials, we came to HFO2, which is hafnium oxide, and this particular ferroelectric material has shown that it is very compatible with our CMOS, and it has shown to be very scalable and robust, and shown robust ferroelectric properties at thickness below 10 nanometer. So this material was very useful for our ferroelectric process. After that, various architectures have been used in NCFET, like in FinFET and in GAAF FETs, and various compact models and simulation frameworks were used to optimize for this device. So these are the materials generally we have used, HFO2 and ZROX. These are the most suitable, till now we have found that these are the most suitable ferroelectrics to be used in ferroelectric layer for our negative capacitance operation. And we have so we have so um, different materials and their thickness effects and capacitance matching we have done, like the thickness of electric layer. This is the most plays a crucial role in determining the stability of the negative capacitance effect, the presence of hysteresis, and overall device performances. And we have used these the NCFETs can be NCFETs were used in different gate stack configurations, like metal, ferroelectric, insulator, semiconductors. Like we have a metal layer, after that we have a ferroelectric layer, then we have an insulator, and and another uh, MFMIS, which is metal ferroelectric, metal insulator, semiconductor. So these are the two, you can say, configurations we have used NCFET there. So basically, what is the principle of NCFET? So main, as the name suggests, negative capacitance field electric transfer. So it has negative capacitance. So what does negative capacitance mean? Negative capacitance mean that when you raise the applied voltage, the stored charges actually decreases. So the capacitor behaves as if its capacitance were negative. Like we have all know that Q is equal to CV. So when we increase voltage, capacitance also increases. But here it is reverse. if you increase the voltage, the capacitance will decrease. So why negative capacitance? Some researchers suggest putting a negative capacitance layer in the gate of a FET so the transistor can switch more sharply, as there will be less charges. So it will be very easy to on the transistor. And this is a typical negative capacitance expression given by Landau, Ginsburg, Demnischer, and Landau Kalatnikov theories, which model the free energy landscape of ferroelectrics as a function of polarization. Here, alpha, beta, and gamma are the properties of the material. Material dependent coefficient, P is the polarization, and E is the electric field. So the negative curvature of dou 2f by dou 2p square is less than 0 in the energy landscape corresponds to the negative capacitance region, which can be stabilized by placing the ferroelectric in series with a positive capacitance dielectric. I have to, as you can see in uh, this picture, that negative capacitance is placed in directly series with the capacitance of the gate and that channel, and after that we have substrate. So basically these are the expressions which tell us how the negative capacitance work and how steep subthreshold slope, which I already explained why it is needed, and how it is used in voltage amplification. So the main need of NCFET is to achieve steep subthreshold slope and voltage amplification. The hallmark of NCFET operation is the achievement of sub 60 millivolt decade SS, which translates to faster switching, lower operating of voltages, and improved energy efficiency. Uh, so when an FET works in the subthreshold region between two gate voltages, VG1 between VG1 and VG2, so subthreshold swing can be calculated by this formula, where delta VG is our gate voltage, and IDS2 and IDS1 are our drain voltage as a threshold region. So it is this formula can be determined by two terms, n cross m. So what are n cross m? N is a transport factor related to carrier movement, and m is body factor related to how gate voltage affects the channel surface potential. So this formula can be break down into two parts, like how much the surface potential changes and how much the gate voltage is needed to create that change. As you can see that delta Vg, that we have delta Vg and delta phi s, which is the surface change in surface potential. So for a normal FET with a positive insulator capacitance, and for a positive insulator capacitance, the subthreshold swing S cannot be smaller than the thermal limit, which is I already told 60 millivolt decade. But in NC FET, if the insulator shows negative capacitance while capacitance of the substrate is greater than 0, then M can be less than 1. Actually, by utilizing this formula, we can achieve the negative capacitance by putting different values of the N and M. A typical NC-FET replaces or augments the gate dielectrics of a MOSFET or FinFET with a ferroelectric layer. So actually, if you ask me what is the main difference between a FinFET and a MOSFET is FinFET and NC-FET is that in MOSFET we use oxide layer, insulating layer, but instead of using an oxide layer we use an ferroelectric layer to reduce its subthreshold swing so that it can change its state from off state to on, meaning like we can switch faster from off state to on state without increasing its supply voltage. So because of this we can use it in low power applications. So I before I already told about that MFIS and MF MIS. These are the these are the two stacks in which NCFET have been used and achieved good results. So this is the formula for VG if we apply a gate voltage in this NCFET. So VG is equal to VFE, which is the voltage at the ferroelectric layer, plus VOX, the oxide layer, and this is the surface potential. So in negative capacitance region, our change in voltage with respect to current with respect to charge is less than zero, meaning the voltage across the ferroelectric decreases as polarization or charge increases, means negative capacitance property. Consequently, for a small increment in VG, the change in surface potential is larger than unity, leading to the voltage application within the device as it is shown in this formula. If we increase phi s by decreasing this capacitance of Fe, then its value will be greater
Excuse
than
me,
1.
sir. As we are running on a schedule, it would be really good if you could like summarize the research in like 2 minutes or something.
Okay, ma'am. Okay.
Yeah, thank you.
So this as we can see, this change in value is greater than 1. So this helps in amplification of subthreshold swing less than 60, allowing NCFETs to operate efficiently at lower supply voltages while maintaining high drive currents. So these are the performance matrices and experiment results. Actually, we have not done that. We have not performed these experiments. We have studied different papers uh, and analyzed what results they have achieved. As it is not an that it is only a review paper, so we have limited resources. So these are the parameters on this on performance matrices like subthreshold swing and switching, power and energy benefits, endurance, retention and reliability. Specialized performance matrices like NCFETs were performed on analog and energy harvesting devices, which consume a large amount of energy. So a recent demonstration used NCFETs to improve rectification energy efficiency in weak energy 2.45 gigahertz microwave wireless transmission, highlighting novel application spaces. So this is a typical model for an FET. This is the typical capacitance model. This is the capacitance of the insulator layer. This is surface potential. This is the capacitance of substrate, and this is our ground, and this is the supplied voltage. All are in series. And this is a capacitance diagram of an NCFET. This is a typical device structure of an NCFET. Here you can see that we have source, drain, substrate, channel. This is the ferroelectric layer we are talking about. This is gate. So literature review. Actually, we have analyzed 20 research papers, and all these.
Hello. Hello, Akshay. Sorry to disturb you. Can you please go to the conclusion slide?
Okay, ma'am. Okay. So these are the applications in which so these can be used in ultra low power digital logic, high performance processors and computing devices, and use in IoTs, wearable and battery operated devices where we need less energy. So e- basically these are very useful in ultra low power consumption devices. And this is a typical comparison we have done between MOSFET, FinFET, NCFET. NCFET using HFO2 and NCFET in 3D structure.
Which
All
one is
these,
better here? Yes, which one is better?
ma'am, actually on different parameters they are different. If we typically talk about subthreshold swing and like switching mechanism, then we have NCFET, because as I already told that it has less subthreshold swing, so it can be switched faster. and as and key if you see key advantages like it can be used in voltage internal voltage voltage amplification, and here
Okay.
and typical
Okay.
and here are the challenges and open questions like what about it is facing challenges about what about its histories control, scalability and process integration, reliability testing. Actually it is not it is a new technology, so its rel- its reliability testing is still going on so that it can be used in a daily life or in commercial processes. And it's a benchmarking. Actually it's if you see its benchmarking and results are not that much available, so if the protocols are standardized so that this new technology can be used for in many fields. Fu- Future directions and recommendations. Basically we have to do a much better research and development in materials like optimizing HO2 variants, ZROX dopants and heterostructures to improve ferroelectric stability, reduce hysteresis and enable skilled integration, like how much further we can minimize this device size. Device circuit co-design. We can use ML assisted compact models and other AI tools and circuit level studies to actually know its optimization for different materials. And as this is a new technology, much more testing is required so that we can have a standardized endurance, retention and various other benchmarks. It's after these if we improve these areas, then it have broadened applications like in analog, in energy harvesting devices where we need less amount of energy, and its main advantage like voltage amplification and rectifications can be exploited. So this is our summary. So from what we have collected, the NCFETs are a promising approach to break the thermal limit on subthreshold swing and reduce energy per operation with HFO2 based ferroelectrics, leading materials research and multiple experimental validations for sub 60 switching. If we improve our problems like hysteresis, reliability and variability, then by using by using advances in our materials in ferroelectrics and other device engineering and much more proper stack configuration, we can broaden our application area of this device. So with continued cross-disciplinary work and standardized benchmarking and experiments, NCFET could become a viable option for low power and specialized applications in future technology. These are our references from where we have done our review for this device. Thank you very much.
Thank you, sir. I'd like to once again ask for Sir Gunjan or Ma'am Vaishnavi, if you're ready, then you may start the presentation. It seems there is some issue with Sir Gunjan. This brings us to the end of the session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2027. All the papers will be getting published within 7 to 8 months. So kindly cooperate with the team of SMARTCOM 2026. And all the participants will be getting their digital certificates within 2 to 3 days. Before we end the session, I'd also like to thank our session chair for chairing. Just a second. Thank you for your valuable presence, ma'am. A token to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation. Thank you, ma'am. Just before the end the session, I'd like to request everyone to turn on the cameras for a quick snapshot of the virtual conference. Thank you, everyone. Thank you for joining us.